he uses a brush to transfer grains containing the male cells from a flower of one variety to the female parts of another variety. So he's busy crossbreeding different varieties of cucumber. So name the grains containing the male cells. So this is pollen grains. Name the process of transferring the grains to the female parts of a flower. This is pollination. Okay, name the process that must take place before seeds are formed. So that is fertilization. So pollination is when pollen goes from one flower or the male part of the flower to the female part of the flower and then gets stuck there on the stigma. Then the male parts of the cell, the actual cell part of the pollen grains, will then get transferred down through the stigma into where the cucumber will form, where the seeds will form. And that part there is pollination. The act of it actually sticking to the stigma is pollination. Fertilization is when that male cell travels down and reaches the ovum, where it will combine to form a complete cell that can then start dividing and forming the seed. So Shen investigates displacement reactions. He adds iron to copper sulfate in a solution in a test tube. A reaction takes place. So copper and iron sulfate are made. Complete the word equation for this reaction. So he adds, so on this side of the equation, we will get iron and copper sulfate. And on this side of the reaction, we will get copper and iron sulfate. Okay, question. Fertilization can be with an S or a Z, I believe. But let's make it with an S so that we all agree. No, I want the pen. Fertilization. There we go. So he repeats this method with the iron and the copper sulfate with some other metals in metal salt solutions. And these are the results that he got. So these are the three metals. He has copper, he has iron, and he has zinc. And then he has zinc sulfate, and iron sulfate, copper sulfate, and zinc sulfate. So he adds this to the opposite of, or the other sulfate solutions. So here we can see whether it reacts. So here are both our copper ones does not react. If we look at our iron ones, one of them reacts and one of them doesn't. And if we look at our zinc ones, both of them react. So put these metals in order of reactivity, starting with the most reactive. Both of our zinc solutions reacted. So zinc is the most reactive. Then one out of the two of our iron solutions reacted. So that will be our second most reactive, and the least reactive will be the copper. Okay. So C here says Shen notices the test tube gets warm when a reaction takes place. What name describes a reaction that gives out heat? This is an exothermic reaction. The opposite of exothermic is endothermic, and that is a reaction that takes heat out of the environment. So Shen's teachers suggest that he change his experiment to find out which reaction gives out the most heat. Describe how Shen changes his experiment. So here, he can use the exact same experiment, except here he has to measure something specific. He has to measure the temperature. So he will use the same amounts of copper, zinc, iron, and the sulfates. And then you will add a thermometer to the test tube as the reaction takes place in order to see how much heat is produced by the reaction. So you will add a thermometer to each test tube. Okay. So now we get to question 6, sound waves. So here we have some sound waves shown on an oscilloscope. Now we need to complete the sentences using the words from the list. So we've got amplitude, frequency, noise, particle, and size. So at A, the wave has the highest, and then at A and B, the wave has the same. So let's go through the difference between these things, amplitude and frequency specifically. So amplitude is how loud a sound is. Amplitude is the distance between there and there. That gives us the amplitude. Or it's the distance between this and that divided by 2. So here we've got a large amplitude, and over here you can see we've got a small amplitude. But if we look at our period or our frequency, sorry, that is how many waves we can see in a second. So over here, in this section over here, we can count. We've got, there's 1 wave, complete. There's 2 waves, complete, 3 waves, and then 4 waves. So there are 4 waves in this section. And if we continue counting, in this section, there are also 4 waves. And in this section, there are also 4 waves. So our frequency stays the same throughout A towards B. So now we can complete these sentences. At A, the wave has the highest amplitude. And at A and B, the wave has the same frequency. Okay. So now we get to question number 7. Angelique and Pierre watch a film about penguins. One scene shows penguins together in a group at a temperature of minus 30 degrees. So he predicts that the penguins in the middle of the group will be the warmest. And now they're planning an investigation to test the prediction. So they use test tubes filled with hot water to represent 8 penguins, and then they label them. So we have test tube A, which stands alone, test tube B, which is there in the middle, and then test tube C, which is those 6 around test tube B. And then they fill them all with hot water. So now they record the temperatures of the water in tubes A, B, and C over a period of time. So name 2 pieces of apparatus they use to obtain the measurements they need. So here we will need a stopwatch, because this will have to happen over a certain amount of time, and we will need a thermometer. Okay, so state 1 variable they need to keep the same in their investigation. There's a bunch of variables. They need to keep the starting temperature of the water the same. They need to keep the amount of hot water in each test tube the same. They need to keep the distances between these tube C's around the tube B the same. So you can name any one of those. So I'm going to go with the amount of hot water. Okay, and then it says explain your answer. So here you need to justify why you said whatever you said here. So let's go through them again. In order to keep the starting temperature the same, you want to have them all start at the same temperature so that you can compare the test tubes A towards the test tubes B and C. and see whether they are actually decreasing in temperature or staying warmer. So that's the explanation that you can give for the starting temperature. The amount of hot water needs to be the same, because if you have a smaller volume of hot water, it will actually cool down quicker. So we want to keep the amount of hot water the same in order to not have that be a factor in our investigation. So let's do that. So this is in tube. And to explain our answer, smaller amounts of water will cool down quicker. So we want okay, there we go. So question 8 says, Aiko and Carlos are investigating states of matter. They do 3 tests on 5 different substances. So test 1 is to fill a syringe with a substance and try to squash it. Test 2 is to put the substance into a beaker, and test 3 is to heat the substance in an evaporating dish. And then they write out a table with their results. Okay. So the questions is going to ask here, which substance is a gas? So let's go through these substances and see what happened. So test A says you could not fill the syringe with the substance, which means it did not fit into the syringe in the first place, which makes me think this is a solid. So let's go through the rest and make sure. So test 2, it did not take on the shape of the beaker. So that still tells me it's a solid. And in test 3, when they heated it up, it melted. So this is most definitely a solid. So test B over here says they filled the syringe, but it could not be squashed. So this means that it's not a gas, because a gas can be squashed in a syringe, but it did fill it. So this should be a liquid. It took on the shape of the beaker, so it's still a liquid. It turned into steam, so this is probably water. So this is a liquid. So test substance C said they could not fill the syringe with the substance. This looks familiar from test 1. This is probably a solid, so let's go on. Did not take on the shape of the beaker, that's the same. And instead of melted, it burnt. So this is still a solid, but this time it may be something like wood that burnt instead of melted. Okay, test D said it could be squashed in the syringe. That right there tells me it's a gas. Okay, you could not see the substance in a beaker. So still a gas, because you can't really pour out gas. Did not do this as nothing to see. They couldn't heat it up. So it's a gas. Number E says they filled the syringe, but it could not be squashed. So again, this looks the same as that one. So this is probably a liquid. It took on the shape of a beaker. It turned to steam, but left a white solid behind in the dish. So this was probably a solution of some kind. But it's a liquid. Okay. So which result is a gas? Choose from A, B, C, or C, D, or E. So number D over here was a gas, because it could be squashed in the syringe. Explain your answer. So gases are easily compressible, and therefore they can be squashed in a syringe. Liquids are not easily compressible and therefore can't be squashed. So and the substance. Okay. So which two substances are solids? So if we go back to over here, we have substance A is a solid and substance C is a solid. A and C. Explain your answer. So they could not fit into the syringe. And did not Now you need to give a property of solids that supports this and not just state the reasons they gave in the tests up above. So here, our property of solids is solids can't change shape easily. Okay. So now we get to question 9 over here. So Pierre and Carlos have 6 boxes. They collect information about the 6 boxes. So we've got some red boxes and we've got some green boxes. And then they've got some volumes, some masses, and some densities. Okay. So let's just go draw some squares around the green boxes so they stand out a bit. So there we've got a green one, and there we've got a green one, and here we've got a green one. Okay. So now Pierre states that the green boxes are denser than the red boxes. Does the evidence in the table support his statement? Okay, so let's go look here. The lowest density of the green boxes is here, that's 78.4. And the highest density of the red boxes is over here, that's 75.6. So the evidence does support his statement because, so here we can go, yes. Explain your answer. So here we can go, the densities oh, yeah, that's mass. My apologies. So ignoring that, here is our densities, and there is our densities, and we get to the same thing. Here's our 3 densities of the green boxes. We've got 7.2, 9.8, and 6.4. And here's our 3 densities of the red boxes, 4.1, 6.3, and 1.2. So it's the same thing. So here we've got 6.3, and it is lower than the lowest of the green boxes. Let me just get rid of that over there. So the lowest of our green boxes is over here, which is 6.4. So the reason is the same, but thank you for spotting that I was using mass instead of density. So the densities of the red boxes are all lower than the lowest Okay. So Carlos says that the largest box is the most dense. Does the evidence in the table support his statement? Let's go find the largest box. So that means we need to look at volume, and our largest box is over here, box A. So let's go look at box A. It has a volume of 15 and a density of 1.2, which is the lowest of all the densities. So no, the evidence does not support the statement. So explain your answer. The largest box Okay. So, question 10. So here we have 4 giraffes. They have different patterns on their bodies. So tick the boxes next to the 2 sentences, 2, that prove they are all the same species. Okay, they all eat the same food. They can all breed with each other. They share similar features, live in the same habitat, and their offspring would all be able to have young. So here is a slight trick. They can all breed with each other. We do get animals such as ligers and all sorts of things like that, which is a lion crossed with a tiger and all sorts of strange mixed breeds of the big cats. The problem with ligers is they're all infertile. Their kids can't have kids. So they can breed with each other, but they are infertile. So their offspring can't have young. So here, an actual characteristic of the same species is that their offspring is able to have young. So there is our 1 tick. So now we can look over here. They all eat the same food, live in the same habitat, and share similar features. So these 2 over here can describe other animals that also live in this habitat. For example, here we've got savanna areas, and they are eating leaves. Elephants also live in the same sort of environment, and they could also eat leaves. So this is not the things that show that these are the same species. So they share similar features, will have to be. So there we go. Okay. Question 11 says, the diagram below shows a model of an atom of an element. So we've got a nucleus and we've got some electrons floating around. So name the part of the atom labeled X. That's an electron. Describe how you can tell that the element is in group 4 of the periodic table. Use information from the diagram. So in the periodic table, the groups are the ones that follow the columns like that. So the group we are in over here is the amount of electrons it has on the outside. We've got hydrogen at the top over here, which means it's got 1 electron in its outer valence. And then below it, we've also got all of the ones that have 1 electron. Group 2 all have 2 electrons, and so forth. So here, how do we know it has 4? It is in group 4. It's got 4 electrons. So that is our reason. Okay, what happens to the size of the atoms as you move down group 4? So now we're in group 4. We've got 1, 2, 3, 4, so over here. But now we are moving downwards. So as we go down, remember, our lightest elements are at the top. So we've got hydrogen, which is only 1 proton and 1 electron. And as we move down, we will end up with them having more protons and more electrons. So the size of the atoms increases as you move down a group. So here in group 4, as we move down, what happens to the size of the atoms? The atoms get bigger. Or larger size, and so forth. Okay, question 12. The diagram shows the addition of different colors of light. So complete the diagram by writing the correct color in each box. So we've got green and red over here, and green and red together make yellow in terms of light. Here we've got red and blue. Red and blue together make, in terms of paint, it'll make purple. In terms of this, it would make magenta. And then green and blue will make cyan light. Okay. So question number 13 says, the diagram shows part of a food web in a large lake. Okay, so now some organisms are missing from the food web and are shown by the boxes. So identify the 4 organisms using the information. So we have algae, which is eaten by mosquito larvae. Okay, so algae it's eaten by mosquito larvae. So one of these two is mosquito larvae. It doesn't really matter which, so let's go here. Okay, water fleas also feed on algae. So here we've got water fleas. Okay, sticklebacks are small fish that eat water fleas and mosquito larvae. So these two get eaten by sticklebacks. We've got that so far. Fish such as perch and pike eat sticklebacks. So one of these is perch, so the other one over here will have to be pike. Okay. And then pike and otters are predators that compete with each other for perch. So over here, we have otters. Okay, and that is all we have time for today.